Today I'm going to go over different Unit 4, Lesson 4 independent practice problems. Let's go ahead and jump right in. Let's look at this first problem. This problem states an orthocenter is the center of intersection of three. Well, we learned that the orthocenter is defined as where the altitudes of triangles intersect. So the orthocenter is where altitudes intersect. So we're looking for the word altitudes. The first answer choice says angle bisectors. The second one says altitudes, so we'll choose B as our answer. The second says medians, and the third says perpendicular bisectors. The orthocenter is where altitudes intersect in a triangle. Let's go ahead and move to the next problem. This problem says, in which figure is point G an orthocenter? Well, we just learned that the orthocenter is where the altitudes of the triangle intersect. So we want to identify which of these different diagrams contains altitudes. Remember that altitudes look very similar to something that looks like this. So we want different altitudes that intersect at the orthocenter. Our orthocenter is G. As you can see here, there are only two different diagrams that contain this symbol of an altitude. So we can go ahead and cross out those that do not. And let's look at A. As you see in A, different lines are intersecting through the orthocenter, but they aren't altitudes. They are just simply line segments, so we can eliminate A. On the other hand, altitudes are being intersected at the orthocenter in D. Here are different altitudes which intersect at point G, which indicates our orthocenter. Let's move on to the next problem. This problem states, in which type of triangle is the orthocenter on the perimeter of the triangle? So we're trying to find in what type of triangle is the orthocenter on the triangle. Well, we learned that the orthocenter's location depends on the type of triangle. It is inside for an acute triangle, outside for an obtuse triangle, and on the triangle for a right triangle. So we're looking for on, which means right triangle. So there we'll select answer choice A. Let's move on. This problem states, in triangle DEF, DG is equal to 10 centimeters. What is CG? So we have CG. Well, in order to identify CG, we want to remember what we learned about the centroid ratio theorem. The centroid ratio theorem told us that the distance between the vertex and the centroid is twice the distance between the centroid and the side opposite the vertex. So here would be our vertex. This would be our centroid. And then we would have our vertex on the opposite side, or our side opposite the vertex. Therefore, the distance from the vertex to the centroid, is 2 times the distance from the centroid to the side opposite, as we saw. So we know that from the vertex to the centroid, we have 10 units. Then we can solve for the distance between the centroid to the side opposite, or from G to C or C to G, by going ahead and dividing by 2. And finding that CG is equal to 5. So A would be our answer choice. Let's look at our final problem. This problem states that point G is the centroid of the triangle ABC. AG is equal to 5x plus 4, and GF is equal to 3x minus 1. What is the distance of AF? Well, in order to find the distance from A to F, what we need to do is add AG plus GF to find the entire distance of AF. So therefore, what we're looking to do is to add 5x plus 4 plus 3x minus 1. But in order to do so, we need to solve for what x is. The way to solve for x is to actually go ahead and identify the relationship between AG and GF. Using the centroid ratio theorem, we know that from our vertex to our centroid is twice the distance from our centroid to our side opposite. So basically, the distance of AG is 2 times the distance of G and F. So then we plug in what we've been given. So AG is equal to 5x plus 4 is equal to GF, which is 3x minus 1. And now we can go ahead and solve. So I'll distribute my 2. That gives me 6x minus 2 equals 5x plus 4. In order to solve for x, I need to go ahead and isolate my x. So I'll do I will do plus 2, which gives me 5x plus 6 equals 6x. I'm going to move my 5x, which gives me x is equal to 6. Once I know that x is equal to 6, I can go ahead and plug that into my equation over here and solve for the entire distance of A and F. So x is equal to 6. I'll copy this over. Oops, that was an accident. X is equal to 6. So AF is equal to 30 plus 4 plus 18 minus 1. So AF is equal to 34 plus 17. So AF is equal to 34 plus 17, which is 51 degrees, thus making answer choice D our answer. I hope this was helpful. If you have any additional questions, please feel free to reach out.